me go ahead and share my screen. So this talk, actually, out of curiosity, does anybody recognize the image? It's an obscure TV show reference, but it's a
Star
no. It's there's an old 1980s time travel show where this was the handheld time travel device. In any event, what I'm actually going to talk about is the HP Voyager series of calculators. This was I've been curious and interested in this set of calculators of late, and so I thought as we were looking for a set of talks, this might be an interesting one to talk about. This was a 5 model. It was originally intended to be a set of models in the 1980s that HP imagined, would have a product lifetime of like 2 years. There was a 5 model series, and they used RPN as did many HP calculators in that era with a 4-level stack. They used this. This was back in the era when HP had their own chips, and they used the NUT processor at the time, and they had the feature that all the calculators in this series end with the letter C. Because they had what was considered at the time a novel feature called continuous memory, which just meant that the memory of the calculator was battery backed up, so that if you turned it off and turned it back on, you'd have the state that you left there. This was one of the first set of calculators that had LCDs, 7-segment with an option for both periods and commas. And every calculator in the series was keystroke programmable. And William Kahan, who was a numerical analyst, was involved in the design of these calculators. And he's actually one of the folks that was responsible for the IEEE 7554 standard, the current floating point standard. So there were 5 calculators in the series originally. These had there was a basic scientific. This was actually added later. It was a sort of a low end model that came out. The first in the series was the HP11C, which is this mid range device, and then the 12C, which is a business and financial calculator. And this one in particular is of note because it is still in a evolved form sold today. It is, I think, as far as I'm aware, the only sort of major mass market RPN calculator that is widely sold. And there's the HP15C, which is a high-end scientific, and then the only calculator that I'm aware of that was sort of mass marketed for computer programmers, so the HP16C. So we'll look at each of these and talk about some of their interesting attributes. So, like all the calculators in that HP sold in this era, they typically used a 4-level stack, and as you entered values, similar to fourth, but with some quirks, there's the stack would shift down, and you'd lose the deepest item on the stack, and your numbers would get entered at the top. And when you push the enter key, what actually happens is a little bit like a fourth dupe. The top value gets duplicated down, and you've now got the value sitting at the top of the stack. And if you enter another number, it replaces the value there. So subtly different than sort of at least my mental model of a fourth stack. And then as you in general, as you put numbers in, right, they go down the stack. If you do an operation that manipulates just the top of the stack, it will, typically stay in place. But if you do an operation like plus that consumes values, then what will happen is that the deepest element, that T element, will get duplicated, and then you'll get everybody shifted back up again. So in your head, you can think of it a lot like a fourth stack, but there are these quirks to it. There are keys to let you do manipulations, a little bit like fourth stack ops. There's a swap operation that swaps the top 2 elements, And then there are rotate operations that exist throughout the whole family that let you cycle through the four elements. There's a whole interesting lineage of like how HP got here in terms of what they built. So there's an early desktop calculator, the 9901 HP 9901, or I believe it is, where the four elements in that one stack were actually visible on a larger display, and they didn't quite have the mechanics in the form that later calculators did. But the Voyager series came out, I think, at a moment when they had sort of done a series of calculators that were innovative and novel, and this was just sort of hitting their stride in terms of the sort of the quality of the design and the thoughtfulness of having a whole family of them that were all built out of the same form. There's also this peculiar quirk where after you do an operation, the prior value of whatever it was in X or at the top of the stack is kept in a separate location you can access it with a key, and all the calculators in this family have it. So we'll start kind of talk about each of these one by one. The 10C is sort of the minimalist of the lot, and a common theme with all of them is that they have this horizontal landscape design, which was novel at the time, and then they will make use of all of them except for the 10C have two function keys that are colored in yellow and blue, which has got this nice visual contrast, and they're thought of, I think, as fairly elegant because of their the look of the calculator. This one had basic trig functions, and all of the calculators in the series have this sum button where you can actually sum pairs of elements. So you can either sort of in your head think of it as summing up values to calculate an average, things like that, or a standard deviation. But it actually, as you push it, it's actually gathering up an X and a Y for two values, and then you can calculate like a linear regression with values. And here you'll notice that there's the shift key and then the swap key. And then, as I mentioned, all of the calculators in this series have the ability to be programmable, and they typically will store something on the order of like 100 steps and it's remembering each individual key press, and we'll look at that in more detail when I show some emulators. Typically, the layout, there's a lot of commonalities with the layout as we go through each of these. You'll have the numbers on the right, the enter key. The position of the buttons is virtually identical, and the only difference is sort of the assignments of it. So here's the 11C. You'll notice it's a little bit richer. It adds some operations for conversion of hours, minutes, seconds. There's where the 10C is missing log operations. Some of those are available, or actually, sorry, it's not missing them. They're hidden and a little differently placed. Here you've got kind of a more full set. There's also a little bit better support on this one for building up a complicated program. There's an ability to have subroutines with a go sub operation. Now, in these calculators, there's sort of two patterns that you'll see for how memory locations are referred to, or program locations are referred to. In some of them that are more simple, you'll end up referring to them by their numerical position in the program storage. But on some of them, there's support for labels. This one, I believe, straddles that midpoint. It doesn't do the labels, but does have the ability to have a subroutine. And then the 12C is probably the most interesting of the set, just because it stuck around the longest. So this one is caught on in the financial community. It's actually still one of only two types of calculators that you can use when you're taking the chartered financial analyst exam. And the key thing that it does that is interesting is that it has the sort of time value of money calculation built into it, so you can specify sort of the unknowns in the equation of number of periods and interest rate, the initial value of a particular thing, and then a payment, and then the final value, and it will calculate the unknowns. And so you can do things like figure out the what interest rate would you have to charge to get to a certain thing in a certain period of time, or given a certain payment that you could afford, what's the amount that you could maximally borrow, things like that. And then it also has a bunch of date calculation options, and again, it's programmable like the rest of the set. And this one was popular enough that in around, I think it's 2003, they made a what was called the Platinum version, where they did a redo of it. They used some variant of a 6502 inside of it, increased the amount of memory for program storage by a factor of 4. And it's similar, but they also, the one sort of thing that they added to it was support for a non-RPN mode. You can switch it out of RPN mode, and there are options for parentheses and things like that. It is interestingly, I think within the financial community, the sense you get is that part of why people want to use RPN with it is you get muscle memory, and it can be very efficient. And so, although it's an option, you'll see these YouTube videos of folks where they get the thing and then decide that they'll figure out how to use RPN with it. Here's the back of this calculator. They show a bunch of examples of how you might do an interest calculation, and then here they're showing which of the storage locations it will accumulate the different sums that are necessary to compute averages with this sum button. If you wanted to, you can also compute averages and linear regressions and so on with it. And then here's the 15C. The 15C was the sort of the nicest one as a scientific calculator in the set. It even has support for matrices. You can do some linear algebra operations with it. It has support for complex numbers. You can put it into a mode where the stack actually has is a series of complex numbers, and it also has quite a bit of options in terms of the programs. There's an option for labels in the program, so you can label a memory location. And then here's the back of that calculator, and it shows examples of how you can get the put in a series of points and then get the linear fit for it and stuff like that. Oh, it also has a solver, and so you can and an integrator, and so it will actually, you put in a program, and then it will run that program repeatedly to calculate values, and then can look for roots or similarly calculate an integral across it. And then here's the really odd duck of the set. It's a programmer's calculator, the 16C. And this one lets you operate in different bases, and it has operations for like left shift and right shift. You can configure the word size to match your machine. You can configure it to do 1's complement or 2's complement, or a bunch of different options, and it'll also do floating point conversion back and forth. So there you go, Kevin. Very nice. Here's a lovely table from Wikipedia about sort of the set of options that are present in the different members of the family. Typically, there's sort of trade-offs here around the button space and the feature set, and so only on the 11 and the 15 and the 16 were there labels, whereas you end up having to operate with numerical locations. Some of the others, different options in terms of the comparisons you can do, and there's some operations for doing increments and decrements for loops, and some flags that also can make it more feasible to do loops in these. So The cool thing about this series of calculators is it's gotten a lot of interest. So there's a lot of folks who put energy into emulating it. There's a whole range of different levels of emulation. The 12C actually has the property that because they've kept it alive to this day, there are variations of it sold. And the current ones actually have an ARM chip inside. There are also clones of it that have been made by this Swiss Micros company, and yeah. So anyways, let's take a look at some of these. These are all. This is the kind of the nicest set of web emulators that I've been able to find, and it's nice to be able to show something on a web page. And so these calculators, if I wanted to put in 22 and I push the enter key, and then I say divide by 7, I get something like that. And and as you'll see, you can it is a very RPN-like machine. Let's say I put in a 1 and a 2 and a 3 and a 4. Whoops! And actually, let me do a 1, 2, 3. And I don't want to hit enter because an enter is a dupe, and then I flush the 1 off the stack. But if I now hit this rotate key, I can cycle through rotating the stack around. Let's give a simple example of, let's say I wanted to create a program. I can start a program, and location 0 on all of these calculators is special. It's sort of the start location for each of them. And then implicitly what will happen is that as you, there will be a go-to back to 0. That's sort of the null operation that's stored in the program space to allow the program to run once and then be available again. So let's say we wanted to do something really simple like take a 2, and you'll notice that when you enter the program, the way that the program gets encoded is it will show the row followed by the column of the key that was pressed, except for the digits where they are all just the digits preceded by 0. So we got a 2, and let's say we wanted to do times 2. So notice that's down in row 2, and then 0 is the 10th column, so the times key. And then let's say we wanted to add a 1, and then we're done. We'll exit programming mode. And so now if I put a 2 and then I hit run, I get 5, and if I put 6, I get 13, that type of thing. And so, and it's slow enough that you can actually see it going. There's a single step operation that you can use to look at stuff. You can store into numbered locations. So I could, for example, store that into location 5, and then if I put some other number on the stack and then decide I want to recall location number 5, I can bring that back. Moving on, let's look at a couple things with the 11. So here, it gets a little bit richer. A commonality in all of these is that there's a set of clear operations that are on the left-hand side, and you hit the F key and then clear the items. Another thing is that they will do a nice job actually with rounding to digit places. So for example, if you put in pi, you get 3.14. You can change the width here by setting fix, and then you could see more digits of it, and it will round appropriately. So if I do fix and then move it to 4 digits, I'll get that rounding to 6. Let's see. Let's take a look at the 12C. The 12C has these options for the time value of money calculations. So you could do things like, let's say I had let's say I've got a 10-year mortgage, and I want to hit this 10-year key to store that in here. And let's say I want to do 5% compounded monthly interest, and if I'm borrowing $1 million as my principal value, then my payment will be this much monthly. So Let's see what else. What else is interesting to show? Let's clear the registers here. Let's say I had a bunch of numbers, and I want to average them, and I can sum them up, and then when I'm all done, I can look at their average. I can look at their standard deviation. So that's the 12C. The 15C. Now we get into sort of the richest set of operations. Oh, actually, I forgot one thing I wanted to show with the 12C. One of the things I think that's kind of interesting with the 12C is that it also has a notion of doing date calculations. So, for example, and there's an option to toggle whether you use sort of European style dates with the month, the day in front. But let's say I wanted to, today's meeting is on February 22nd, 2025. And let's say that I enter that, and then let's say I wanted to figure out, the next meeting I think is on the 22nd as well, as it happens. And let's say I wanted to now calculate how many days until the next meeting. I can hit this delta days and find out that it's 20 days later. Or similarly, you can do arithmetic with days and figure things out. Like if you wanted to know what date is in 90 days. In fact, yeah, let's do that. So today is 2/22/2020. Whoopsie, that clear. 2/22/2025, and let's say I wanted to know what day will it be in 90 days. I can find out that it is on May 23rd, and the 5 is that it is the 5th day of the week. So, cool. All right, let's look at the 15C. The 15C, as I mentioned, has this the solver. Let's see if we can use the solver. So, say let's say we start a program, and we're going to want to have a program that takes on the stack the value that it's going to compute whatever function for, and then we're going to want to calculate the result. So let's say we did the square. And then let's say we do something like 1 minus, and then we got to exit. Actually, we'll do let's see, we'll exit program mode, and then let's say we, oh, I forgot. Okay, let's try that again. Clear the program memory. We got to label our program on this one. So we got to go back into program mode. Let's label it with label A, and then let's do what we did before. So we'll square, and then we'll subtract 1, and then we'll exit program mode. And let's say we now go ahead and push solve and A, and that didn't do what I thought it should do. All right, I'm going to call that demo fail because I should have thought of a better function to do this on. But we'll move on to the next calculator. All right, so this is the 16C, and here it starts up with a 16-bit word size. You can configure it with this W size option, and so you can do things like let's say we wanted to enter some number, and then we want to convert it to hex, and we'll discover that that's the value in hex. If we left shift to that value, and then we go back to decimal because it's in 2's complement mode, that's the value it will have. On the other hand, if we were in unsigned mode, that's the value it has. Similar operations, there's ands and ors. We can do, let's say we go back into hex mode here. We can do a not on this thing and get a value. There's masking operations, all kinds of fun options. So what ideas, if any, can we get from this series of calculators? I think, to me, one fascinating thing is that the financial community is kind of held on to this particular calculator. I think there's maybe some conservatism of how to approach money there, but I think there's also an aspect in which RPN can actually be pretty efficient, especially when you've kind of tuned it for a keyboard. I think one thing that's fascinating with these calculators is that you get by pretty readily with 4 levels. In practice, when you're putting in complicated expressions, you usually flatten them enough that you don't need a very deep stack. And I think sometimes, Chuck in particular, I think has oftentimes been skeptical of deep stacks, and I think that there's maybe something to that, especially for the data stack. I find particularly this series particularly beautiful. I think that the look of the keyboard is very nice. I don't like the 12C Platinum for whatever reason. I think that it's, even though it is complementary colors with the red and the blue, they somehow visually clashes to me. But the original series has this very nice look, and I think that also probably plays a role in the 12C sticking around. I think there's also kind of an interesting aspect to thinking about these keyboard keystroke oriented devices. I think it's easy with Forth to slide into having large, complicated identifiers, but one of the things that's nice with Forth is just having a very simple, small set of operations laid out, and these calculators do quite a lot with a fairly limited number of buttons. I'm reminded of, I've got some random scientific calculator I have floating around that will also do linear regressions. And it's like so many button presses to get into something. You have to go into a special mode to do a stats thing. You have to go enter a series of values, and then you go navigate a menu to find a thing. And it's just so hard. And this calculator, each of the calculators in this series manages to let you, enter a series of either XY values or single values the same way, just because there's that stack there, and just because it all sort of fits together as a set, and then you're just one button press away from the things you want to get out of that. So I think there's something to be said for the simplicity of it. In any event, that's all I've got. Back to you, Kevin. And I'm duly impressed. That was a 16C you held up there?
It was.
I am verily impressed.
For years, as I said in the text, for years, this was my constant companion, frequent use. The keys are very nicely made. I think this is my second or third one. Bill's got his. And the thing is that I think I had a scientific version as well, because there were frequent applications for that. So I got out of the 2 calculator business, but still for many years, long after they were still sold any place but EduCalc was the company that got the parts and stuff from HP after they were out of the calculator business. But thank you so much, Brad. That was wonderful. And now is the time where I apologize to Bob, because it is now past the appointed hour. Bob, can you join us next month and deliver your talk?
Sure.
Thank you so much for your
Brett.
patience.
I got the script here anyway. That saves. In our psychophysics lab, we got an HP 35, which absolutely was revolutionary. because although we had all these PDP-8, CDC around to be able to actually do scientific calculations directly, man, it eliminated the slide rule and all of that. But my father, around 1980, bought an HP calculator, and I think it was the HP 40, and it was financial operations. And by the next talk, I will have present values and future values and all of this by essentially just transliterating Arthur Whitney's K algorithms, because he's got all of that. But this is the thing: is one purpose of COSI is to replace those things and have it as convenient as any of those things, but for all of your sorts of problems. Anyway, it's all fired up, but okay, next month.
We're looking forward to it. And we'll be specifically allocating a time slot rather than my usual half-ass arrangement. I still feel that the program chairman should be immediately suspended and permanently replaced, but that's just me. All right. Thanks to everyone. It's so nice to see you all. I look forward to these monthly meetings. And if you're going to speak next month, I would be grateful for a early email with a topic and a 2-line description. I wanted to ask Joe, who has left, Joe O'Connor. Oh, Joe's still here. Joe O'Connor, are you going to be here next month? You going to present? It's not clear that he's listening. He's present, but not present. All right. With that, one of the many things I learned from Robert Heinlein. Motion to adjourn is always in order. It takes precedence, and it's not debated. It is voted immediately. So let's pull the plug, stop the recorder. See you next month.